Hi, I'm Bob. Let's do the computer exercises together. They are from Chapter 4, Multiple Regression Analysis, Inference. In the textbook Introductory Econometrics, the 7th edition, I use Stata to complete all the computer exercises. You can download all the datasets from the link below. Let's do the first exercise. The model is used to study whether campaign expenditures affect election outcomes. For the first question, we notice that it is a level log model. The outcome variable's unit is percentage points. Beta 1 measures the percentage points change in the vote received by candidate A, as campaign expenditure on candidate A increases by 100%, holding the other two variables fixed. Or equivalently, beta 1 divided by 100 is the percentage points change in candidate A's vote when A's expenditure increases by 1%. For the second question, the null hypothesis is that the sum of beta 1 and beta 2 is 0. In other words, the negative impact of B's expenditure offsets the positive effect of A's expenditure. For the third question, we use the dataset and type describe to look at the information of the variables. We run the regression and report the results in the usual form. For the individual significance test, the t-statistics of beta 1 hat and beta 2 hat are large enough to reject the null hypothesis at any conventional significance level. Candidate A's vote increases by 6.08 percentage points if her campaign expenditure rises by 100%. The vote received by candidate A decreases by 6.62 percentage points if candidate B's expenditure increases by 100%. We could not use the results to test the hypothesis in part 2 because it is a linear combination of the parameters. So in question 4, we rearrange the variables and define theta 1 as beta 1 plus beta 2. We regress vote A on the log expenditure A, log expenditure B minus log expenditure A, and party stress for A. And we directly have the t-statistic for the estimate of theta 1. That is minus 1.00. From the t-distribution table, the 10% critical value against a two-sided alternative with 169 degrees of freedom is 1.645. Because the absolute value of the t-statistic is below the critical value, we fail to reject the null hypothesis that beta 1 plus beta 2 is 0. In other words, we could not reject the null hypothesis that a 1% increase in A's expenditure will offset the effect of a 1% increase in B's expenditure. An easier way to see the significance of the estimate is to look at the p-value of the t-statistic. It is 0.320. it implies that we could not reject the null hypothesis at even the 30% significance level. Let's do computer exercise number 2. We use the dataset and describe it. The model relates the median starting salary for new law school graduates to the median LSAT score for the graduating class, the median college GPA for the class, the number of volumes in the law school library, the annual cost of attending law school, and the law school ranking. For the first question, the null hypothesis that the rank of law schools have no ceteris paribus effect on the median starting salary is beta 5 equals 0. The two-sided alternative is that beta 5 does not equal 0. We regress the log salary on LSAT, GPA, log library volumes, cost, and rank. From the result window, the t-statistic is minus 9.54 and its p-value is 0.000. We reject the null hypothesis at the 1% level. When the law school ranks one higher position, for example from position 5 to position 4, the median starting salary increases by 0.33% on average, holding other factors constant. The effect is statistically significant at the 1% level. We can check the range of rank by typing. Summarize rank. It ranges from 1 to around 170. If the law school ranks 10 positions higher, the graduate starting salary will increase by 3.3%. In the second part, to test the individual significance of LSAT and GPA, we look at the result window and find that the t-statistic for law school SAT is 1.17 and its p-value is 0.244 against a two-sided alternative. It suggests that we could not reject the null hypothesis that the LSAT does not affect salary after controlling for the other 4 variables. The t-statistic for GPA is 2.75 and its p-value is 0.007 against a two-sided alternative. It suggests that we reject the null hypothesis at the 1% level, and we can conclude that GPA has a significant effect on salary. One more unit in the median college GPA increases the median starting salary by 24.8%. It seems a huge effect, but when we summarize the variable GPA, we find that it ranges from 2.73 to 3.82 with an average of 3.30 and a standard deviation of 0.20. So a one standard deviation increase in the GPA is estimated to increase the starting salary by 5%. To test whether the LSAT and GPA are jointly significant, we can type test followed by two parentheses. We write the two restrictions in the two parentheses. The F statistic is 9.95 and its p-value is 0.0001. It suggests that we can reject the null hypothesis at the 1% level and conclude that the two variables are jointly statistically significant at the 1% level. We could also type test LSAT equals GPA equals 0 to do the F-test. The third question is also about the individual and the joint significance tests. We add the size of the entering class as an additional explanatory variable, and we find that the t statistic is so small that we cannot reject the null hypothesis at any conventional level, that it has no significant effect on the salary after controlling for the other variables. Similarly, the t-test for the faculty size suggests that it does not statistically significantly affect the salary, holding the other factors fixed. They are individually statistically insignificant. We can do the F-test to see whether they are jointly significant. We run the unrestricted model with the two additional variables and then type test followed by the two restrictions. The F statistic is so small and its p-value is so high that we fail to reject the null hypothesis that the size of the class and the number of faculty are jointly insignificant at even the 30% level. As a practice, we could do the F-test by hand, based on the sum of squared residuals form or the R-squared form of the F statistics. We have already run the unrestricted model. The sum of squared residuals is 1.57, and the R-squared is 0.8440. Next, we run the restricted model without the two additional variables. The sum of squared residuals is 1.60 and R-squared is 0.8416. Be sure to use the same sample size in the restricted model as in the unrestricted model. That is why we use the condition statement if E sample in the Stata command. The number of restriction is 2. The unrestricted model has 131 minus 8 equals 123 degrees of freedom. Plug in all the elements in the F statistic formula and we obtain the same result. For the last question, some variables could be correlated with the ranking variable, but not included in the model. Some graduate students' demographic characteristics could affect the starting salary, and they are also likely to be correlated with the ranking variable, therefore leading to omitted variable bias. Such factors include gender, race, and region. Let's solve computer exercise number 3. We first rearrange the variables and define theta 1 as 150 times beta 1 plus beta 2. We now have an equation containing parameters beta 0, beta 1, and theta 1. Or we can write beta 2 in terms of theta 1 and beta 1 and plug this into the original equation to obtain the same equation. We find that the equation has a composite variable equal to squared feet minus 150 times bedrooms. We generate this new variable first and then regress the log of price on it and the bedrooms. The estimate of theta 1 is 0.0858. When a 150 square foot bedroom is added to the house, the price is estimated to increase by 8.58% on average. The p-value against the two-sided alternative is tiny, 0.002. It is statistically significant at the 1% level. We can read the 95% confidence interval from the result window. It is from 0.0326 to 0.1390. That is, the housing price increases from 3.26% to 13.9% as a 150 square foot bedroom is added to the house. Let's do exercise number 4. The unrestricted model is the long model with the two parents' education variables. There were 1,191 observations. The R squared is 0.0387. The restricted model is the shocked model without the two parents' education variables, because the null hypothesis is that they have no effect on birth weight. Be careful here to use the same sample size as in the unrestricted model. In Stata, we use the statement if E sample in the command to indicate we use the same observations as in the former model, that is the unrestricted model. When mother's education and father's education are dropped from the regression, the R squared falls to 0.0364. The number of restriction is 2. The unrestricted model has 1,185 degrees of freedom. We plug all the elements in the R squared form of the F statistic and obtain 1.42. From the 5% F distribution table, the 5% critical value with 2 and 1,185 degrees of freedom is 3.00. The F statistic is below the critical value, so we fail to reject the null hypothesis. Mother's education and father's education are jointly insignificant at the 5% level in the birth weight equation. In practice, we use the Stata command test to do the f-test after running the unrestricted model. We put the two restrictions inside the two parentheses, followed by the command test. We have the same result. Next, let's solve computer exercise number 5. The model relates the total salary of the baseball players to the years in the league, the average games played per year, the career batting average, the home runs per year, and the runs batted in per year. The original estimate equation is as follows. Drop the variable of the runs batted in per year, and we have the following estimated equation. Comparing the two equations, we find that the home runs variable becomes statistically significant at the 1% level when the runs batted in variable is dropped. The size of the coefficient is more than double. For the second part, we add the 3 additional variables to the model. We find that only the runs per year variable is statistically significant at the 1% level. The t-statistic is 3.43, and its p-value against a two-sided alternative is 0.001. The estimate suggests that one more run per year will increase salary by 1.7% on average, holding other variables fixed. The other two variables are individually insignificant at any conventional level, with small t-statistics and large p-values. For the third question, we could simply type test followed by 3 parentheses and put the restrictions in the parentheses. The f-statistic is tiny, 0.69, and the p-value is big, 0.5617. We fail to reject the null hypothesis that the 3 variables are jointly insignificant at any conventional level. We could also estimate the shocked restricted model and compute the f-statistic by hand, and it should lead to the same conclusion. Let's do computer exercise number 6. It is about testing whether another year of general work experience has the same effect on wages as another year of tenure with the current employer. The null hypothesis is beta 2 equals beta 3. The two-sided alternative is that beta 2 does not equal beta 3. There is more than one way to do the test. We could estimate the unrestricted and the restricted models and compute the F statistic. But here we use another method since the second part asks us to construct a 95% confidence interval. So we should define a new parameter, theta 1, for beta 2 minus beta 3. The null hypothesis becomes that theta 1 equals 0, and the alternative becomes that theta 1 does not equal 0. We rearrange the variables so that it contains the parameters beta 0, beta 1, theta 1, and beta 3. We generate the new variable x3 equal to the sum of experience and tenure. We then regress the log of wages on education, experience, and x3. The coefficient on experience is theta 1. Its t-statistic is 0.41. We can find from the result window that the 95% confidence interval is from minus 0.00736 to 0.01126. Since 0 is inside the confidence interval, we fail to reject the null hypothesis that another year of general work experience has the same effect on wages as another year of tenure with the current employer against a two-sided alternative at the 5% level. Remember that the 95% confidence interval corresponds to the 5% significance level against a two-sided alternative. Thank you so much for solving the computer exercises with me. See you next time. Thank you for watching this video and subscribing to my YouTube channel. See you next time.